Okay, this is a video about showing you what we did with PrologMUD that made it useful, or will make it useful, and really easy to program. If you are new to Prolog, then there's a couple tutorials that you probably want to do, and if you're not new to Prolog, these are tutorials you may have already done. If not, then I suggest when you look at them, you're going to see what PrologMUD is all about. These are on the AMSI website. We didn't write these. These were written in 1993. And published in PCAI magazine. What this, and what a lot of people who have done this tutorial realize how perfect Prolog is for interactive fiction. And proof of that is with the declarative nature that we see in these database predicates, we're able to describe this glyph of these connected objects. And we can say that the duck pen is next to the yard. The yard is next to the house in the woods, and surely it is. We can say what objects are inside the location. In the duck pen, there are ducks and an egg. So this is kind of like saying noun, verb, object, noun, verb, object. Location being a state. Being within that state is, to me, a verb. So the location of or is ducks are, which is a version of be or is. So they are being at the location. So I justified why I could say verb or noun, verb, object in this, but we might delete that out of the video. Anyhow, so with this really small database, we're able to describe a small piece of the world. In Prolog, you're able to write things, and a compiler in the simplified form, and a compiler compiles them, and it creates a program. Obviously, that's what compilers do, but it's an untyped language, and so we didn't have to declare that the word closed was something special and the word location was something special, unless you're programming in Mercury or, say, Turbo Prolog, which these people in 1993 might have actually done, use Turbo Prolog. You describe relations in Prolog using a rule, and that's what this connect XY is. So what this rule says is X is connected to Y when next to X is Y, right here, and it is open. So, for example, a duck pen, a yard is connected to the house because it's open, but the duck pen is not connected to the yard because it's not open. It's closed in the situation. So within this tutorial, they load these facts, and then they ask questions about the facts. Like they say, is the yard connected to the woods? Yes. Is the woods connected to the yard? Yes. What all is the yard connected to? All these different things. Was that correct about the yard being connected to the duck pen? Evidently it was, at least in the database section right here. Okay, so since this is an interactive fiction tutorial, they want to create a verb called goto. And what goto does is it looks for the location of your body, figures out what's connected to it, tracks where you're at, asserts where you're going. So when I say go to X, I want to go to X. And so it takes my location, makes sure I can get to X, it removes my location and adds a new location, putting me at X, and tells me about it. If it was unable to, if this failed, which is the most likely thing to happen, then it would write, you can't get there from here because they're probably not connected. So say probably not connected, but so the goto command is an example of a verb implemented in Prolog. We also have predicates that help us understand the world. Like we want to find out if the gate is open in this particular duck world. Let's see, we have a gate right there. So we have a connection between the duck pen and the yard, and it uses a gate. Up here, no one actually mentioned the gate, but they are going to bring into existence the idea of a gate. And they do that by saying, if there's an opening between the yard and the duck pen, then there is an open gate. If there is a closed, actually, I tell a lie. What it's doing is asserting, if the player's mission was to open the gate, it would make sure that the gate is now open and the duck pen and the yard are next to each other and connected and it's open. If this mission was to close the gate, it would remove that openness or the closedness, whichever was there, and add the closedness to it. So this is another MUD verb, and these are other MUD verbs. We can chase things, we can take things. Okay. Also, in this particular example, they have this idea of daemons, which are processes that run all the time in the MUD, where they run every so many ticks. And what it does is every time the ducks go tick, it sees you in the same location in the pen. Okay, if the ducks see you in the yard, if you're in the yard, the ducks are in the pen, the ducks and the ducks can get to the yard. It'll remove the ducks from the duck pen, put them in the yard with you, and then it'll let you know the ducks have ran into the yard with you. Okay, so instead of me just going totally over the code, I'm just trying to show you how simply in this tutorial code is written to describe interactive fiction. So that was this article. I'm going to take a peek at this article and see if it can be see what we can see out of here. So here's an example in this tutorial of creating a text adventure game. Starts you out in the kitchen where you see apple, table, and broccoli. And here's you playing the game. And then through the rest of the tutorial, it actually allows you to write the game. And by the time you're done, I believe the game is only, let's see how many lines, probably not that many. Okay, here's the entire game. It's not, oh yeah, actually, you know what? We were looking at two different programs, so let's see here. Okay, so I'm going to grab this here. And here's the adventure game. Starts here, called Nanny Search. Copy, and then we're going to paste it into a new text file. And it is only 560 lines long. That was why I was pasting into a text file here. And if I take off that, it's only 514 lines long. Okay, so this is a Prolog program that allows you to play a text adventure game. You've probably written one in BASIC or in Inform 7. This is not, won't feel as natural as Inform 7, obviously, because this wasn't meant to be that way. What this does, though, is it shows you how simple the command parser has been written in. A winning situation, a quitting situation, help command with the right. Okay, so, but let's look at how much fun this game was. Looks like someone was having a blast playing it. So, and they were able to do that for these 500 lines. So I suggest do the tutorial so you get comfortable with how a MUD or a text adventure game is written in Prolog. And then here is the system on a little mix of steroids and maybe a little bit of crack. Okay, so PrologMUD is simply these tutorials gone wild, and so for example, we have the description. We had ducks we saw in that one tutorial. Well, here's the decision-making system that a duck might use. In this case, it's a monster, not a duck. Okay, so the call recording is on, evidently, and so we're starting in on wherever we left off. So when we're looking at the LogicMUD source code, we're going to tie this back in. Hopefully this thing recorded everything about the LogicMUD or the nanny tutorial. Actually, let's see, while we're here, let's go back to our tutorial for a second, in case it didn't. Okay, so we have this really fun looking game, and the source code for that was here, nice and simple. It's actually very readable if you read Prolog. If you want to take something, it has to be here, it's got to be takeable, and then you move the thing from wherever it's at to having it, and now you respond with you now have the thing. That's very declarative. Well, LogicMUD is just basically almost the same thing. We just kind of add a predicate for if Joe wants to take something, we put agent take thing, so is here, we might put something like agent is here, and the thing is here. Actually, thing, okay, is, we're going to say @loc, @loc, you use find ring place. We're going to say @loc. And we're going to say the thing, I might say is a thing takeable. And now we're going to move the thing to to being possessed. You might say something like agent. So the reason I just did that, I wanted to say that from the nanny code, we can produce pretty quickly something that's more compatible with PrologMUD. There's further compatibility that we'll do, or that's required. For example, for the take command to be implemented, we have to do something like this. We have to wrap it, and so it goes into our meta interpreter like that. And now, so any agents, whether they're written in English or if they're programmed in English or not, can now call the take thing. So this agent tells the world it wants to take something, and instead of respond in this case, we might say dmessage. Actually, what we probably might want to say is event, show event at the location. And then here's our event. We've said it in English. I like to have this thing going on where most terms that are ever used in these predicates have a couple very easy to understand data types, like in the situation where we have this list here. This list is English. If we have a goal that looks like now seen, well, this is a term, now seen agent, now seen take agent thing. Or actually in term form, termerized. So most of the time when we're going to see something in Prolog, it's a declarative version of something. We see something in lists, we're going to pretend it's English. That's going to be true with like 90% of the source code when you see these things. So like in this case, this is termerization. And one thing about termerization is we try to keep as much of the code working from this level and not from English. And then to convert back and forth to English, we are using a definitive clause grammar. Here's how we understand verbs. Transitive verbs mean it takes an object afterwards. So sit is a intransitive verb, and looking means it doesn't take an object. Transitive verb takes an object. So if we drop something or take something, that is transitive. Okay. So anyway, so we can say pick up sticks by using, let's see, so how did they do this? Okay, so a command is a transitive verb plus a noun phrase, and that's, or a command could be simply an intransitive verb, or it could be a go-to type action. So from this here, actually I was thinking it was going to be smaller, so I was going to impress you with how little code went into the parser, which actually very little code did go into the parser. There we go. That shows, this is the entire read eval print loop. Reads command, executes the command. This actually parses the command here. And this executes it. This is our termerization. Make the command from a list structure. Oh, so what actually the way get command works is it returns a command, but it gets a list from the user, returns that form I was talking about, where we have goal, list to goal. And so that's a parser. Allows for a few synonyms. Anyway, if you do the tutorial, you'll be able to understand what's going on here. Okay, so you probably afterwards realize how much mileage you got out of such little work. Well, LogicMUD's premises were going to do that together in a large, massively online role-playing game, where now we take that system and put it, make it more complete and easier for people to share code.